Hello and welcome. Welcome to my YouTube channel PHARMAVEN. In my previous video, we have discussed about how to perform media fill concern regarding the media fill in lyophilized products. And that was halfway I prepared. I have discussed with respect to the various topics with respect to guidance for industry EU Annex-1. Let us continue with the video with more exciting guidances, more exciting examples, which will help you to better understand how we can simulate media fill for the lyophilization product. So let us move ahead with the understanding guidances part again. So coming to UNX1 again, this is revised UNX1. Was we know what is revised UNX? It has been revised recently in August, and it has a very clear indication, very clear guidance is what to be done in terms of various activities, including media fill into the aseptic process simulation. So in developing APS plan, aseptic processing plan, consideration should be given to the following points. What are those points? Let's understand. That is identification of worst case condition covering the relevant variables such as container size and line speed and their impact on the process. So what can be the container size? Like we have 2 ml to 100 ml container size in small volume parental. So what can be our container size based on the what we are doing on the line, what containers are we are going to fill on the line, and what speed. And the outcome of the outcome of the assessment should justify the variables which are selected. So this is one point. Then determining the representative sizes of container closure combination to be used to be validated. Bracketing or matrixing approach. For example, we have 2 ml to 30 ml size, and in between there are 10 ml, 15 ml, 20 ml. Then we can simulate 2 ml and 30 ml and provide it's a bracket which covers the in between vial sizes. This bracketing approach is well considered for the validation of the same container closure configuration for different products where process equivalence is scientifically justified. When your filtration filling process is same, then same container closure configuration for different products may not need repeat simulation just because there is a new product. If there is no significant changes such as in your existing process there is only one filter, you have two filter, and in your new process there is one filter. In this specific process there is a change in your certain simulations which are different than the previous validated media fill, then you may have to repeat the media fill. Then maximum permitted holding times for the sterile product and equipment exposed during the aseptic process. So this is very crucial in terms of how long we can continue filling in my routine production. It has nothing to do with the chemical compatibility of the product. Chemical compatibility of the product comes from the process validation. Media fill gives you a window how long you can fill in terms of aseptic process simulation, in terms of not impacting the sterility by prolonged filling. Normally we are doing filling for the up to the 24 hours or 27 hours or 30 hours based on our product filling length, and that 24 hour or 30 hour allows in case something goes wrong during the product and it goes extend up to the 24 hour, then this media fill comes as a defense that there is no impact on the sterility by extending to my routine commercial products filling till 24 hours or till 30 hours. Now coming to the new again another guidance, that is PDA Technical Report 22. PDA is Parental Drug Association, a group of experts who prepares the guideline across the industry to help the pharma better, parental pharma better. And this guideline states, let us understand what this guideline has to say. It says the methods employed for the lyophilization process simulation are generally similar to those used for the solution fields with the addition of the activities such as. So lyophilization process simulation is generally same as the solution field, but what are the new things in this? What are the additional simulation into the lyophilization product? These are the transport. Transport means once the filling and half stopping is completed, it goes up to the lyophilizer door to actually load the vials inside the lyophilizer. And there are different methods. One is conveyor. You can see here the conveyor. Another is, let us take me the pointer. Yeah. So you can see here this is a conveyor, it is transported, and this is automatic loading system. So it will push the entire rows of the wires inside the lyophilizer cell. This is sort of manual loading. Both ways are currently there based on the what is the advancement within the that specific manufacturing plant. Some have old system, some use mobile LFs to transport the this filled wire to the lyophilizer. Some have conveyors, some have automatic loading and unloading. These all sort of systems are there, and all are has to be validated during the media fill. Each and every process has to be validated during the media fill to prove that this process of loading is not impacting my sterility. Now coming to the loading, it has to be loaded. Simulation of freeze drying. Discussed in the previous video, we don't have to freeze the media. We don't have to pull too high vacuum so that media will boil out of the containers. We don't have to do, we just have to simulate the steps at ambient temperature or 25-degree temperature. It can be chosen, but we don't have to freeze it, first point, and we don't have to pull very high level of vacuum in media fill. We don't have to simulate the exact parameters of the product. We just have to simulate the process. Then stoppering, unloading and closing. So stoppering, unloading and closing. So before stoppering we have to do the aeration. That aeration will be with the compressor, not unlike nitrogen into the product. It has to be done with the compressed air. Unloading and closing of the lyophilizer chamber. So this is how the steps which are additionally involved into the lyophilized media. Continue with the PDA technical report 22. Simulated load, unload with short and hold time. It has two cycle options. What cycle we can choose? First is simulated load, unload with short and hold time. So we have to simulate loading and unloading of the lyophilizer product, but with the short hold time of the lyophilizer cycle. So what is that? So containers are filled with the media. Stoppers are partially inserted, loading into the lyophilizer at ambient temperature. The guidance says ambient temperature. A partial vacuum insufficient to cause the boiling of the media is drawn. For example, 0.5 bar. It has to be done. Partial vacuum insufficient to cause the boiling. Then vacuum hold for the predetermined time, 30 minutes for example. Chamber is vented and stopper are treated. So this is short and hold time. In this vacuum pre-hold determined time, we have to simulate in pulses. Why? Because in my actual cycle there will be pulses of vacuum and nitrogen purging, vacuum nitrogen purging to maintain the vacuum at certain level. So that pulse, to simulate that pulse, you draw the vacuum, hold it for 30 minutes, again bring it to the atmospheric pressure with compressor, then again draw the vacuum, then again bring it to the atmospheric pressure. They do 3-4 times to simulate the actual process which is occurs during the media fill at actual product. Why? This also simulates the nitrogen line or compression line, whether it is properly sterilized or not. Then chamber is vented, stoppers are seated. What are the advantages of this process? In this process, media is not completely frozen. One thing. So fewer concern with regard to microbial survival in freezing process or ability to media to support the growth. So in this media not freezing the media. So the questions which can arise if we freeze media, whether it retains its ability to support the microbial growth, that concerns are gone. That is one advantage. Second, this process focuses on loading and sealing activities, which are presumed to be the greatest source of potential contamination. So in my entire filling line, in my entire lyophilized media, what is my highest risk activity? One is filling with intervention, then loading and unloading, loading specifically. In loading, we have to do a lot of activities. If it is manual loading, there will be a lot of simulation. Even if it is water, there is a lot of simulation. That while travels longer than the liquid media, liquid product, it goes to the conveyor, it goes to the automatic loading on it. That is pusher is there. It keeps pushing, keeps pushing. There is lot of simul, and if there is wire falling there, if there is breakage there, then there are a lot of other intervention can be added in this activity. To simulate those, it is very crucial. So with short hold time, I am not freezing my media. That is first and advance. And second, I am simulating all loading and unloading activities, which is sort of severe than the liquid product. What are the practical aspect with this? So simulated loading and unloading with shorter hold time. So loading is as per normal product. That is one. No freezing, set temperature 25 degree, we can do this. Partial vacuum of 0.5 bar, product vacuum goes into the micro bar, so we don't have to pull that high level of vacuum. Then simulation of vacuum pulses, addition to 1 bar if I am considering 1 bar as my atmospheric pressure, and vacuum to the 0.5 bar to simulate the vacuum pulses at actual. 3 vacuum pulses with hold of 30 minutes each, vacuum break with compressor. This is how we can simulate it. Automated cycle with all the steps at 25 degree, primary drying and secondary drying at 0.5 bar. So this can be done manually, or we can create an automated cycle of media where the entire temperature will be at 25 degree and we'll be putting the vacuum values like 0.5 bar, and we can put the pulses. Addition with compressor. Now coming to the practical aspect, what will happen if it is simulated for longer hours of holding similar to the product in lyophilization? What will happen if we simulate it for the long time as per the product? For example, 40 hours, 50 hours, 60 hours. I have seen cycle up to 96 hours. What will happen? Exact simulation of media fill as that of product lyophilization will have possible reduction of microbiological levels after aseptic manipulation, which will not solve the purpose of aseptic simulation. So understand, lyophilization will have possible reduction of microbiological levels after aseptic manipulation, which will not solve the problem. Exact simulation of block, then it will, there is a possibility there's reduction in microbiological level. Then carrying out the lyophilization cycle and freezing the media will be same simulation as that of product lyophilization. However, this freezing of media will reduce microbial level of some contaminants. If we are freezing the media, then it will not support the growth of microbes as it is at the normal room temperature or ambient temperature. Then aseptic process simulation of lyophilization process. The scope is not to check the lethality of the freezing. This is must be understood. In lyophilization process, freezing is not a sterilization process. Freezing is just to achieve a solid product, which will then go for the sublimation process. So here the purpose is not to kill the microorganism by freezing. It's just for the lyophilization process. So we don't have to simulate the freezing as a process. Hence, freezing of media and the formation of ice crystal is unfavorable to the microorganism. Hence, this should be avoided. On the contrary, freezing will not favor the growth of microorganisms, so we have to avoid it. Now practical aspect, continued unfrozen media and complete vacuum. What will happen if you have unfrozen media, that is liquid media, and will put very deep vacuum? What will happen? If the media is not frozen, then the lyophilizer may get contaminated due to unfrozen media which is left under vacuum similar to the product lyophilization vacuum level. So this is the disadvantage, that media will come out of the container. If it is complete vacuum drawn, and it may cause the media solution to get out of the container and contaminate the lyophilizer as a well fluid loss from the container, and is finally this may have a serious effect on the viability of the microorganism, and the ability of the media to support microbial growth will be impacted. This will in turn make aseptic process simulation invalid. So what will happen? The media quantity will be reduced from the container, so it defeats the purpose of providing enough quantity. And also there will be questions on the ability of the my media to support the growth of microorganisms. So these two things which will prevent us from pulling the complete vacuum during the media fill. It's obvious we must not draw the complete vacuum. Now hold time duration into the lyophilizer. How long we have to hold? In general, the course and processing time should be long enough to challenge all the stress, the process, intervention, the supporting environment and the operators. All efforts should be made to perform all routine interventions. So how long we have to continue the lyophilized media? Long enough to simulate the process, all the intervention, to simulate the surrounding environment and to simulate the number of operators. And we have to perform all the routine intervention. This is a ask, this is a requirement. All routine, which is called inherent, and corrective intervention we have to do into the media fill. Otherwise, there is no surety that this intervention will not cause any microbial contamination in commercial production. During this, we ensure the integrity of lyophilizer chamber by testing the lyophilizer's post-sterilization cycle. Therefore, no additional benefit is drawn by holding the media fill vials for longer duration, since the lyophilizer's integrity is maintained throughout the cycle. Out of this cycle, hence it is not necessary to carry out lyophilization cycle as per the actual drug product. So there is no point in holding the media inside the lyophilizer, because once you close the chamber, it is integral. It is integral for the lifetime, or not for the lifetime. I'll say it is integral for the product cycle. And after that, we are doing the post integrity of the chamber, post sterilization. So there will be assurance that chamber maintain its integrity. So there is no at all need to simulate the entire cycle. As compared to the lyophilization hold duration for filled vials in lyophilizer, the chances of contamination for partial stoppered vial is more during the process, such as empty vial transportation, media filling, sampling, half stoppering, rolling of vials into the lyophilizer. So my lyophilization cycle is not the bigger challenge. Bigger challenge is transportation, media filling, when we do sampling, when we do half stoppering, when we do loading and unloading inside the lyophilizer. These are the more challenging steps during the lyophilization cycle. Now PDA technical report 22 also had simulated lyophilization approach, where you have to simulate the entire cycle. Containers are filled with media, stoppers are partially inserted, loading in lyophilizer at ambient temperature, a partial vacuum is applied, maintained at a normal duration of lyophilization cycle. So normal duration means it is cycle is 30 hours, then 30 hours, because each cycle is 40 hours, then it will be a 40 hours. Then chamber is vented and stoppers are seated. So this is how it works for the simulated lyophilization cycle as a whole. Now what is the advantage? Media is not frozen, so fewer concern with regard to microbial. This is again short cycle. Also we are not freezing the media. And another, what is the disadvantage? This is time consuming to perform. Extending the simulation through the entire lyophilization cycle. So we are not getting any advantage out of extending the cycle, as we seen into the previous slide. There is no absolute advantage of extending the full cycle. So better approach, perform all the simulation, all the intervention, but do not simulate the lyophilization cycle for the full duration as per the product. uh, for the simulator, almost no one simulates full life cycle. I have never seen that approach. Real challenge in the lyophilizers is the simulation of loading, unloading and intervention, which I discussed. Extending cycle to full duration is not the worst case scenario, as the chamber is sterile, vacuum and aeration lines are sterile, and partial simulation will be enough to challenge the process. Partial simulation means 2, 3 or 5 hours of simulation of vacuum and pressure pulses as per the primary drying and secondary drying requirement to the pressure which is to the vacuum which is not very high. It's enough to simulate the cycle. And post cycle leak test ensures the integrity of the chamber during the cycle. So we don't have to simulate the full life cycle, and it is time consuming process, and practically we are not getting any advantage out of it. Now there are some special considerations in PDA technical report 22. Let's understand. Freezing of media. In order to maximize microbial recovery, freezing of media is not recommended. That is one. We should not freeze the media. Vacuum levels and duration. The vacuum must not be so low as to permit the medium in the container to boil out, thereby invalidating the simulation. So we don't have to pull two vacuum, so that the media will be boiled out of the container, and it will invalidate the actual media fill simulation. Use of air. So wherever anaerobes have not been detected, so in your environment, if there are no anaerobic bacteria, then entire simulation should be done with compressed air and soybean casein digest as a medium. Then the use of an inert gas and anaerobic medium, that is alternate fluid thioglycolate medium, would be appropriate where the persistent presence of strict anaerobic organisms has been confirmed in either environmental monitoring or more likely during end product sterility testing. So when we have to do the anaerobic media, when we have strict anaerobic organism has been confirmed in the either environmental monitoring or during the product sterility testing, then only we have to go for the anaerobic media. Otherwise we have to go with the aerobic media and air. Now batch size process. What is the acceptance criteria? Production batch small scale if it is less than 5,000 units, we have to simulate the actual batch size of product. And there is one example with this. If your actual batch size is, for example, 4,000, and if you are going for the actual product simulation 4,000, then what can go wrong is if you don't get full 4,000. In your commercial you are getting 4,000, but in your actual you are getting, for example, 3,800 because of fill rejects, because of filtration losses, then it will not be in your actual simulation. So if batch size is less than 5,000, then and your actual batch size is 4,000, so you must at least get 4,000 good media field vial for the simulation. So it's always better to go for higher than the actual batch size if the batch size is less than 5,000. For the mid scale, 5,000 to 10,000 units, it's not less than 5,000 units, but better to simulate actual batch size. For example, your batch size is 6,000 or 7,000, then go beyond 7,000. Considering that the duration for the 5,000 will be less, and if it get extended, it will not be actual rig simulation. If you are not getting the filling the enough number, or as per the actual product batch size you are not filling, then that can be questioned. And large scale, if batch size is more than 10,000 units, your actual good units should be not less than 10,000 after your filling. Good for good 10,000 vials, at least 10,000 vials for the incubation purpose. So normally people do target 11,000 containers, 11,000 vials, so they'll get at least more than 10,000 considering all filling losses, all filtration losses, all rejection. So this is how batch size of the APS should be simulated. Size of run is sufficient enough to cover all inherent and corrective interventions. Irrespective of batch size, your media field duration should be such that it will cover all inherent, which are routine, and corrective, which are non-routine interventions. And sometimes it is divided as a runs to extend the media fill of 10,000 vials or 5,000 for the longer duration. It divided into the runs. Or irrespective of product batch size, minimum 5,000 units shall be simulated if the lyophilizer capacity is available. So if your lyophilizer is 5,000 vials, then you have to simulate 5,000 vials. If lyophilizer capacity is not available to accommodate 5,000 units, maximum capacity of the lyophilizer shall be considered for the media fill batch size. All cells not necessarily required to be loaded, but filling duration should simulate maximum time for actual product filling. So if you have large lyophilizer but your batch size is limited, then you don't have to go for the entire filling of the, or going for the batch size which fills the entire lyophilizer. If it is not your batch size, if batch size is less, then you have to simply go for the as per the batch size requirement, considering this criteria 5,000 or 5,000 to 10,000 or more than 10,000. But filling duration should be at actual. So if your actual filling duration goes for the 12 hours for the live product, your media fill must go beyond 12 hours. That is how you can cover your filling duration. Sufficient number units should be filled to accurately access the potential for the commercial batch contamination. See, you have to simulate as per the commercial batch sufficient number. If batch size is less, then we have to simulate fill sufficient number, so it will simulate all the intervention during the commercial batch. Now tracking of filled containers with interventions. In lyophilized media fill, the first loaded container is large. See, there is a difference in liquid media and lyo media. In liquid media, your first filled vial remains the first filled vial. But in lyophilized media, the vial you load first inside the lyophilizer will be the last vial to be unloaded. For example, first shelf will be loaded, it will go up, then second, then third. And if you when you start unloading, you start from the last shelf. For example, it is 8 shelf, then you load first, but you unload 8th one first. So these numbers get reversed. So in lyophilization media, the first loaded container is last unloaded. So tracking after unloading is to be linked with the filling time in reverse order. That is one. Tracking with reference to the intervention time with the full containers shelf-wise when vials are loaded on the shelf and not in trays. So if you are loading the entire shelf at a time and there are no trays, then we have to consider entire shelf time, and we have to track that this shelf took 30 minutes to full load. Then what were the intervention during the 30 minutes? And if you are getting contamination in that cell, then you have to link those contamination with the intervention performed in that 30 minutes. If it is tray wise, you can always put tray numbers and you can track it. Intervention technique for self and automatic loading and unloading system is there. If it is automatic loading, then we have to track the intervention per self. Scope of using date and time through laser using filling, which will be just before loading. If you have technology available, we can laser imprint the date and time on the vial outer body after the filling. So it will provide us exact date and time. Now same filling line for liquid and lyophilized. So should only one lyophilized media is okay? So when filling line has both liquid and lyophilized products, approach usually is seen as smallest container for liquid, largest container for lyo, and smallest container for lyo if it is different than the liquid container size. So if the same line has two different vial sizes, or same line has liquid and lyo product on the same line, then what we have to simulate: smallest container for liquid, largest container for lyo, and smallest container for lyo if it is smallest container for lyo is other than the liquid. And this is accepted approach. You can have other approaches based on the justification. It's not a guideline requirement, it's not from the guidance, but this is based on the practical experiences as well as some of the regulatory observation which one or other company have received in the inspections. When two lyophilizers are for the same filling line, then what can be done? So one lyophilizer at every 6 months with compatibility justification. So if both lyos are same with same loading and unloading technique, then every 6 months you simulate one lyo here, and in next 6 months another lyo. If both lyophilizers have altogether different technique, that is unloading and automatic unloading, manual loading and unloading, then separate simulation may be necessary. And this ends my presentation on the media fields for the lyophilized product. Hope this is helpful to you. Hope this will make you better aware, and hope I have contributed into some of the understanding about lyophilized media field. Thank you very much for being with me and watching my full video.